Okay, question 2. Scientists no longer accept the geocentric model of the universe, which I've drawn here. The Earth at the centre, the Moon going around the Earth, the Sun going around the Earth, and the stars all going around the Earth. But it was the geocentric model of the universe was the accepted theory for hundreds of years. Explain why the evidence available at the time supported the geocentric model, this model. 3 marks. Okay. Right. Firstly, the telescope wasn't invented until 1608, probably by a chap called Hans Lippershey, who was a German-Dutch lens maker. So they only had naked eye evidence, okay? One mark. Next, talk about what they could actually see. So with the naked eye, they saw the Moon going round the Earth. They saw the Sun going round the Earth and all the stars spinning and appearing to rotate around the Earth. All the time in the same direction. Okay? So they saw everything going around the Earth. They saw all this stuff appearing to go round the Earth. That's what it looked like, okay? 2 marks. For the 3rd mark, I think you should talk about what they felt, okay? This was before Newton and Newtonian mechanics, okay? You can't, well, we can't as well, but they couldn't feel the Earth moving through space. You can't feel it standing on the Earth, right? And they couldn't feel the Earth rotating. So, you know, at the time, it's understandable that they think that the Earth was stationary. So couldn't feel the Earth move. Okay, let's move on. So that'll get you the 3 marks, but just for a bit of extra, you could mention that the stars, they all look like they're at the same distance, don't they? You know, if you ever look up at the sky at night, on a clear night, you can understand why, you know, with limited knowledge, you'd think that they're all sort of on a big sphere around the Earth, just rotating. So you can mention that. Oh, also, at the time they could see these things they called planetos or wanderers. It's where our word for planet comes from. They were seeing the planets, but they didn't obey the rules, okay? The Moon, the Sun and the stars all rotated, but these planets, they could see them, they'd go one way, then they'd move back another way, and then they'd go back again. They would wander through the night sky. And the reason that planets appear to do that from the Earth is that, okay, this model's wrong, okay, this is a geocentric model. In reality, the Earth and all the planets rotate around the Sun, okay? So when you observe the other planets from planet Earth, because the Earth and the other planets all go around the Sun at different speeds, if you watch the other planets and you've got the stars in the background from the Earth, it looks, you're going around the Earth at different speeds. It does look like the other planets are wandering backwards and forwards. Of course, in reality, they're not. They're just going around the Sun like we are. But it's just a perspective thing. If you look at them from the Earth, they do look like they're going backwards and forwards. So they actually tried to come up with geocentric models that could explain this somehow. They had circles everywhere and all sorts of things. So the planetos, the wanderers, were a pain for them. Okay, that was a lot more than you need to write for this question, but that's just a bit of information. Okay, right, you've got your 3 marks. Let's move on. Where are we? Right. Next question, B. The Big Bang theory and steady state theory are two theories about the origin of the universe. The discovery of CMB, the cosmic microwave background, led scientists to accept only one of the theories. Explain why redshift supports both theories, but CMB only supports one of them. 3 marks. Okay. For the first mark, you should say, both theories predict an expanding universe. Okay? So, call it the steady state theory and the Big Bang theory, they both support an expanding universe. Universe. Okay? 1 mark. Next. Okay, we observe redshift with our telescopes right now in the universe. We can see redshift happening. Okay? And redshift suggests that the universe is expanding. Okay? So redshift suggests expanding universe. Right? So therefore, redshift supports both theories. Okay? Okay, 2 marks, at least. Finally, 2 marks. Okay? Finally, the cosmic microwave background suggests that the universe had a starting point, and therefore the CMB only supports the Big Bang theory. Okay, so CMB suggests the universe had a starting point or a beginning, and therefore, CMB supports the Big Bang theory only. 3 marks. There we go. Okay, makes sense? I don't think I want to add anything to that question. Let's just move on. Okay. Right. The next question is going to be talking about the life cycle of stars. So, ideally, I could do with a nice little diagram about the life and death of stars. Okay, here we go. That'll do. Okay, question 2, part C. A star with a mass very much larger than the Sun. Okay, it's asking about the length of the main sequence and whether it ends up as a white dwarf or a black hole. Okay, a star with a main sequence very much larger than the Sun, so we're down here, okay, this route. Does it have a longer or shorter main sequence than the Sun? Our Sun is an average star. Well, the bigger the star, the shorter its lifespan. Okay, so the answer is it has its main sequence is shorter than the Sun's. Okay, and does it end up as a black hole or a white dwarf? Well, it ends up as a black hole. It might end up as a neutron star, but that's if its mass is between roughly about 8 times the size of the Sun and 20 times the size of the Sun. But a really big one, more than 20 times the size of the Sun, will end up as a black hole. And an average sized star will end up as a white dwarf, and then a black dwarf as it cools. Okay, the answer to the question is D. A star with a mass very much larger than the Sun has a shorter main sequence than the Sun and ends up as a black hole. Okay? Which means the mark scheme for this question is wrong, because they said B. They said it has a longer main sequence and ends up as a black hole. No, the bigger the star, the shorter the main sequence. Okay? So the mark scheme was wrong. The correct answer is D, not B. Right. 2C part 2. Black holes. There's my drawing of a black hole. Right, it's asking about their gravitational field, and it's either it allows only electromagnetic radiation to escape, that's wrong, or it allows nothing to escape, that's correct. Okay? Nothing can escape from black holes, not even EM radiation, in other words light. Okay? Even light can't escape. And a black hole is formed when either a nebula collapses, no, or when a very large star collapses, yes. Here's your very large star, it collapses, it explodes in a supernova and leaves behind a black hole. So the correct answer is B. And they actually got that right on the mark scheme. So well done them. A black hole allows nothing to escape and is formed when a very large star collapses. Okay, well that's the end of this question. So what you need to do now is click on my video about the lifespan and life of stars called The Life and Death of Stars. So click on that and watch that right now.